Good day everyone, I'm Samantha Y. Ambasa, leader of Group 4. We are here to discuss our group project, which is Statistical Process Control. And here are the topics that we need to discuss. Basic concept, types, importance and benefits, advantage or disadvantage, process and example, best practices of statistical process control. My group consists of 5 members. They are Kawili, Cruz, Labro, Nugid, and Shoson.
Statistical process control is the use of statistical methods to manage a process or manufacturing method, which is known as SPC. Using SPC tools and techniques, you can keep an eye on process behavior, spot internal system issues, and fix production-related issues. Statistical process control is a well-known technique for keeping an eye on and controlling quality during the production process. SPC for short. During production, measurements of a product or process are used to collect real-time quality data. The three essential components of a statistical process control chart are central line, which is known as CL, for the average, and upper control line, UCL, for the upper control unit, and lower control line, or LCL. For the lower control unit, statistical process control, often known as statistical quality control, is the use of a statistical tool to monitor and manage the quality of a production process. By ensuring that the process is efficient, more products that satisfy the criteria can be produced with less waste.
Good day everyone, I'm Maria Remedios Gavili and I'm here to discuss the types of statistical process measures. Okay, there are several types of statistical process measures that can be used to monitor and control a process. These measures can help identify problems, assess the stability of a process, and determine the appropriate action to take to improve the process. Um, Some common types of statistical process measures include process capability indices. This measure compares the output of a process to the desired specification. They can be used to determine the ability of a process to consistently produce products or services within the required tolerances. Control charts. These charts plot the data over time and use statistical techniques to identify patterns or shifts in the data that may indicate a problem with the process. Pareto charts. These charts can show the relative frequency of different defects of problems in a process. They can help identify the process common sources of defects so the corrective actions can be taken. Cause and effect diagrams, also known as fishbone diagrams. These diagrams help identify the root causes of problems in a process by breaking down the problem into smaller or more manageable parts. Okay, statistical process control. This is a method of using statistical techniques to monitor and control all the process to ensure that it is operating within the predetermined limits. It involves the collecting data, the process, analyzing the data using statistical tools, and taking corrective actions when necessary to keep process within the desired limits. By using these statistical process measures, organized can be improve the quality and reliability of their products and services, reduce costs, and increase customer satisfaction. Thank you.
SPC can help organizations acquire and implement process data in real time, making control charts for more effectiveness. SPC software can collect data and create actionable reports in fraction of the time to create them manually. SPC reduces scrap, waste, defects, and rework, improve product quality to eliminate variation in process and maintain compliance with regulatory and customer requirements. To prevent the special causes of variation occurring if it achieves this object, then the process remains statistically in control. Thus, the process variation is due to common causes only.
Advantage: Statistical process control (SPC) is commonly used in manufacturing or production process to measure how consistently a product performs according to its design specification. By achieving consistent quality and performance, some of the benefits manufacturers can realize are reduce scrap, rework, and warranty claims, maximize productivity, improve resource utilization, increase operational efficiency, decrease manual inspections, improve client satisfaction, reduce costs, extensive analytics and reporting. What are the disadvantages of statistical process control? Image result for advantage or disadvantage of statistical process measures. Disadvantages with statistical process control. While the emphasis of statistical process control is on early detection, implementing the system in a manufacturing setup can take a long time. Additionally, the process of monitoring and filling out charts is time-consuming. PC helps reduce scrap, waste, defects, and rework, improve product quality, eliminate variation in processes, and maintain compliance with regulatory and customer requirements.
Process. How to perform statistical process control. 1. Identify the processes and identify the key process that in fact that output the product of the process that is very critical to the customer. For example, plate thickness. In fact, the products perform a manufacturing company, then consider the plate manufacturing process. 2. Determine measurable attributes of the process. Identify the attributes that need to measure during the production. For example, consider the plate thickness as a measurable attribute. 3. Determine the measurement method and also perform gauge R&R. Create a measurement method, work instructions, or procedure including the measuring instrument. For example, consider thickness gauge to measure the thickness and create an appropriate measuring procedure. Perform gauge repeatability and reproducibility gauge R&R to define the amount of variation in the measurement data due to measurement system. 4. Develop a subgroup strategy and sampling a plan. Determine the subgroup size based on the product critically and determine the sampling size and frequency. For example, collect 20 set of plate thicknesses in the time sequence with a subgroup size of 4. Number 5. Collect the data and plot SPC chart. Collect the data as per sample size and select an appropriate SPC chart based on the data type. Continuous or discrete and also subgroup size. For example, plate thickness with a subgroup size of 4, select X bar R chart. Number 6. Describe natural variation of attributes. Calculate the control limits from the above example. Calculate the upper control limit and lower control limit for both X bar range. And last, 7. Monitor process variation. Interpret the control chart and check whether any point in out of control of the pattern. For example, check X bar R chart. If the process is not controlled, then identify the actionable causes and address the issue. This is an ongoing process to monitor the process variation.
Best practice. Statistical method should be enable data to answer scientific questions. And number 2, signal always calm noise. Number 3, plan ahead, really ahead. When substantial effort will be involved collecting data, satisfying issue not captured, isolated statistical question. Therefore, worry about data equality. Number 5, statistical analysis is more than a set of computations. Number 6, keep it simple, all else being equal, simplicity trump complicity. Number 7, provide assessment of variability, nearly all biological and measurement. Number 8, check your assumption. Every statistical inference involves assumptions that are based on substantive. Number 9, when it possible, replicate. Very good analysis examines the data greatly, looking of partners of any types of research, predicted and unpredicted results. Number 10, make your analysis reproducible in our current framework, publication of scientific result. That's the 10 best practices of statistical process control.